Take a look at absolute values, but with equations, okay, and inequalities, so open sentences. So we're going to interpret the absolute value as the distance between 2 points, okay, the distance. Now, in physics, you guys are going to learn about something called displacement and distance. And we talk about displacement as being the change in the object's position. So displacement could be something positive to the right, or it could be a negative to the left, if you think about the position being further back on the number line. But when it comes to distance, we're literally looking at the length of the segment, or the traveled path itself. So the distance traveled if you walk across the room is going to be, say, like 6 feet to the right. If you walk to the left, it's still 6 feet. It's not negative 6 feet. So distance is really analogous to our absolute value that we're going to talk about today. And then we're going to solve some equations that have multiple solutions to them. Let's take a look at a simple diagram or chart to show us and explain how absolute value works. So when we think about it as the distance between the graph of x and the origin on the number line, here's what we say. And I'm going to point these out as I discuss. This right here, absolute value equal to 1. What could go in for x to make that statement true? What could go in for x? Negative 1 or positive 1, okay? So Will and Niles said negative 1 or positive 1. They're absolutely right. And we'll see on the number line here, there's the negative 1, there's the positive 1. And this simply means the distance between x and the origin. That's how this part would be read, is equal to 1. Again, this right here I'm hovering over. The distance between x and 0, or x and the origin, that's what that physically means, is equal to 1. Okay, and that's very easy to see when we have an equation with absolute value. But when we have an inequality, sometimes it confuses people a little bit. So let's discuss the second row there. Again, this is read as the distance between x and 0, or x and the origin. And that distance is now greater than 1. What numbers on the number line are more than 1 unit away from the origin? Give me examples of some numbers. And they could be decimals, they could be whole numbers, they could be 2. Negative 2. What else? What else is further than 1 unit away from it? Negative 3.
1.1.
1.1. So anything beyond the limits of 1 are further than 1 unit away. So that's an or statement, really. This is really an or statement. Like here, this is the 2 that we were speaking about. This is the negative 2. Negative 1.1 is right in here. So anything that's more than 1 length or 1 unit away from the origin is in our solution set. But that's on this side and on this side. So this is an or statement when we have a variable greater than a number. Okay, again, it's an or statement. These are things that you're going to pick up on, that greater than symbols, when written in this orientation with the variable on the left and the number on the right, greater than symbols always turn out to be or statements. Again, that's why I'm giving you this little rubric here to see. And then finally, the last part, if the distance is less than 1, numbers that are less than 1 unit away from 0 are all decimal values. Less than 1 are fractions, right? Proper fractions. So those are the numbers from 0 all the way to 1, and from 0 all the way to negative 1. So it's this region in here between negative 1 and 1. So this is an and statement. And I can write it with the word and, or I can write it as a compound inequality, as we've been doing, like we've been writing in solution set form. So when we see a greater than sign, we think or. When we see a less than sign, we're going to think and that's assuming that we're in this setup where the variable is on the left and the numbers on the right. Okay, variable on the left, number on the right. Let's take a look at an example, just an equation first, so we can explain how it works, and then we'll go into the inequalities. So the absolute value of 2x minus 4, that quantity, is equal to 14. So the absolute value of it is equal to 14. So it could be what numbers? Again, remember, if this were just like an x in here, right? If this were this, we would say, well, x could be 14, or x could be negative 14. That's how we would do that, right? So now let's apply this rule to what we have. Luca.
2x minus 4 equals plus or minus 14.
Yeah, there we go. So 2x minus 4 equals 14, or 2x minus 4 equals negative 14. Okay, so the same way we would separate that original statement up here, like this, we would separate with the equation down below. And now what we have to do is solve. Okay, so remember, absolute value means it's 14 units away from the origin. So it's either at positive 14 or it's at negative 14. Either way, that's 14 units away from the origin. Solving on the left, 2x is 18, x is 9. Solving on the right, 2x is negative 10, x is negative 5. So we get two solutions from our absolute value statements. Okay, two solutions from the absolute value statements. Questions so far? For those that have not seen this before, what have you seen? Just with numerical values on the inside? Anything else with any actual variables on the inside of the absolute value symbol? All right, because there's another way to solve these. There's a way to solve these equations called graphical solutions, which we're going to do in the next section. So I was wondering if anybody had seen that before, so we have an idea. Okay, so we have two solutions. How do I know that these are both correct? Yeah, plug them into the original to check. All right, so plugging in 9 up top here gives me 18 minus 4 is 14. That is correct. Plugging in negative 5 gives me negative 10 minus 4, which is negative 14, and that is also correct. All right, this one now. Who could step me through how to do this? We don't have an equal sign anymore, so something has to change about this problem. Something has to change about this problem. Go ahead, Charles.
I think you swap the sign.
Okay, so what do you mean?
So it would be 6 minus 4u is less than 5.
Okay.
6 minus 4u is greater than the opposite of 5.
Now, why do you do that, Charles? You're absolutely right. Why is that?
Because you have to set it to 2 different equations too.
But why would you flip the sign and make it a negative 5 there? Go back to remember that little graphic I gave you in the beginning? What did we know about a less than symbol? What did we know about a less than symbol? What did it look like? Look at that little table that we put on the second slide there. A less than symbol is what kind of a statement, Charles?
The distance between x and 0 is less than 1.
Yeah, so it means that you have an and statement. It's that little region in between, right? So what Charles is really doing is he's visually doing this. He's setting up these boundaries to be, it says that this quantity is less than 5, which is like here, and greater than negative 5, which is over here. Well, less than 5 and greater than negative 5 is doing exactly what Charles said. That's what he's doing by writing that statement. He's saying that 6 minus 4u, that whole quantity, is somewhere between there. Now, that's not our answer. I'm just showing you a little diagram at the top. But that's physically what he's seeing. He's saying, well, the quantity 6 minus 4u, this expression right here, is less than 5, right? That's everything here. And it's also greater than negative 5, everything this way. So it's this region in between again. It's again an and statement. So if you want to remember, okay, to put an and word there in the middle, to remind yourself at the end that you'll get an and statement as your solution. You can always flip the sign and negate the other side to see what you get as a result, and that's what Charles started by telling us to do. Okay, but the reasoning is because of the definition of the less than symbol with absolute values. Okay, it's somewhere in that region, and that's what these two statements say. And at this point, you're just going to go ahead and solve these separately. Okay, solve them separately. So let's go ahead and do that. I'm going to subtract 6, giving me a negative 1 there. Subtract 6, giving me a negative 11. Now, since I'm dividing by a negative, what am I going to do? Yeah, flip the sign, please. Okay, divide by negative 4 on both sides, and we'll flip the sign. Oops, and as I say flip the sign, what did I forget to do? Flip the sign. And take a look at your solutions and make sense of them. A number that's greater than a fourth and less than 11 fourths, okay, it's clearly an and statement. Think about your endpoints. How are you ever greater than 1/4? Well, on the number line, here's 1/4. And here's 11 fourths. If it's greater than 1/4, it means it's to the right. If it's less than 11 fourths, it means it's to the left. So we're in this region in between right here. Okay, and we knew that because of the fact that this was an and statement to start. We knew we should get a result with a shaded region in between because of the fact that we had this symbol in the beginning. Okay, we had a less than symbol with the variable term over here telling us that this quantity is somewhere between -5 and 5, while the actual solution for u, not for 6 minus 4u, is between 1/4 and 11/4. How would I write this in solution set form? How would I write this in solution set form? If I'm looking at a range of numbers from 1/4 to 11/4 exclusively. How do I write inequalities, compound inequalities? Okay?
1/4 is less than u, which is less than 11/4.
Yeah. Okay, 1/4 less than u, less than 11/4. Use those endpoints, please. Remember, whenever it's an and statement, it's always going to look like this right here. With u in the middle, the endpoints on the end, and then less than or less than or equal to signs, depending on the problem. Okay? What's an easy way to check that your answer is right? Because this one's a little bit tougher, obviously, because there's many solutions, right? What would you do to check that your answer is generally right, that you think it's right? You have a range of numbers, so what might you do?
We plug a number in that is between, that could be u.
Yeah, exactly. So a number like 1, right, or 2, those integers are in between, because 11/4 is 2.75, and 1/4 is 0.25. So I would test integers like 1 or 2 in my original and see if that is indeed true. Okay? And if you tested numbers outside of this range, like 5 or 6, or a number like 0, that should be false, right? So if you test a number like 0, you should check that you get a false solution because you haven't shaded where 0 is, which is to the left of 1/4. So when you have a range of numbers, it's more difficult to check your answers than if you just have one solution. When you have one solution or two solutions, you simply plug those in. But for a range of numbers, you have to kind of, pick and choose, certain values that are enabling you to check your answer without checking every single one, right? You don't want to check every integer, every possible number in between. And statement. Let's take a look now what happens when we have a different kind of statement. Now, notice that this inequality is written in the other direction as what we had earlier. So if you want to start by doing this, you can, even though it's the same thing, obviously. Oops. Okay, if you'd like to start by writing like that, that's fine. If you flip the whole thing, right, you're flipping the entire thing, you have to flip the inequality sign with it. So when we write it like this, we can see we have an or statement because of the greater than or equal to sign. In the previous problem, again, we had the less than symbol. Now we have a greater than or equal to symbol because I wrote it in that direction. But you don't have to write it that way if you can just see that. That's fine. So Charles mentioned what we do earlier. Who can remind us? What can we do to start this problem? Paul, what do you got?
Switch the sign.
Good. So let's start by writing it normally first, and then we'll go ahead and switch that sign. So there's the first statement, or, and then we'll write the second statement. Okay, so again, we have two possibilities here. We rewrite it the original way we saw it, then we rewrite it, we flip the sign, and change the sign of the numerical value. And this is where we have to solve. What method might I use to help me solve these? What's easier to make these equations a lot easier to get rid of all the fractions?
Multiply by 2.
Multiply everything by 2 in both equations. This becomes 4 plus x greater than or equal to 3, or 4 plus x less than or equal to -3. It just makes life easier. Take these shortcuts, please. I can't tell you how sad I was when I saw people doing long division on the test when you can use a calculator. Like, I let you use it for that reason, so you don't have to make silly mistakes. Okay, please go ahead and do this. Make life easier on yourself. Don't take the longer route. It doesn't make sense. Now we can solve these both. Subtracting 4 on the first side, we're going to get x greater than or equal to -1, or x less than or equal to -7. Can a number be greater than -1 and less than -7? No, it can't. Think about it. Number's bigger than -1, and if we graph these in the number line, we can see why this is an OR statement. Here's -1, here's -7. Greater than or equal to -1 looks like this. Less than or equal to -7 looks like this. So it is most definitely an OR statement. We knew that from the beginning because of the way the orientation of the inequality symbol in the equation, it's in the inequality itself. But we can prove that with our answer anyhow. So if you didn't remember that this was OR the whole way down, and you got these two solutions at the end, just graph them on the same number line. When you don't see that overlap in those solutions, you know it's going to be an OR statement. Okay, so that's it. And this is your solution set, actually. All right? So we're taking absolute value and the idea of what it is, and our variable terms within absolute values, and combining them with inequalities to understand that we can get multiple solution set ranges. Okay, multiple ranges. How are we doing so far? So, if we're going to have two more problems, but if somebody could restate, what's the easy way to solve these problems? Give me some facts about them. I can think of like 2 or 3 facts if you're given one of these problems. What's one thing? If you don't get it, you need to ask a question. But if everybody says yes and asks a question like this, I'm assuming that somebody can respond with a simple fact. But if not, please ask me. Okay, so when you're solving them, break it up by flipping one of the signs and making the negative. Good, that's one starting point. What else?
Two different equations.
It's always going to have 2 parts to it. Good. What else? What are some key facts that we've noticed so far we can look for?
What is the less than sign, it's in greater than sign, it's less than.
Yeah, we can look at the symbol itself to indicate whether it's going to be an AND or an OR statement. When we've seen the less than symbol, we've noticed it's an AND statement. When we saw the greater than symbol, as in this one at the top here, we knew that it was an OR statement. So these are the identifying factors that you need to be, cognizant of. So when you're taking a test, you have to remember, okay, break it up into 2 terms. I'm definitely going to get an AND or OR statement depending on the sign, and I have to remember to negate the right-hand side when I flip it. That's the stuff that I would be remembering when I'm taking a test. So if you struggled so far on some of the work on the last test maybe, these are the kind of notes that you want to write down when you're taking notes. Not just going through the problems, but the key facts that apply to all of them. Okay, like a summarization as you go through this. Just so that when you're doing your homework, you do your homework well. And so when you take a test, you understand how to do this. So let's You guys can maybe get a head start in your homework if you'd like. So this last problem here, we're going to see that we not only have now an absolute value, but we have an absolute value within a compound inequality. Within a compound inequality. Pause for a quick second and think about this. All right? Just think about this mentally. Well, let me just, for the sake of this, put a random variable here. Let's say 3x, okay? Let's say we had this scenario right here. Oh, come on, catch up to me. Smart boy. There we go. So say we had this scenario. How would I go about solving this? And we did this in the last chapter. Nah, what would you do?
Split it up, you go 1 is less than 3x.
And?
A separate one, 3x is less than or equal to 2.
Yeah, and this would be an and statement, right, Noah? Remember that? So that's how we would break this up. So what should I do for what we've got in this problem?
Break it up.
Yeah, break it up. So go ahead, what do you got?
1 is less than the absolute value of 2 minus r. And 2 minus r is, the absolute value of 2 minus r is less than or equal to 2.
Yeah, so now we've got two statements already. And we still have absolute values. So it's like we have two separate problems that we have to work on right now. We've got this one on the left where 1 is less than absolute value of 2 minus r. And this one on the right where absolute value of 2 minus r is less than or equal to 2. So now we've got two more problems to do. So what do you think is going to happen at the end? How many parts of this are we going to end up getting? 2 from the one on this side and 2 from this side. So 4 parts that should be here. This is like 2 of those last problems in one. Okay, so we broke it up to start because we had a compound inequality. Now we have to go about doing this. And the way this works, if you remember, is we break this into 2 statements. And we break this into 2 statements. And if you forget that it's and, or whether it's and or, it's okay for now. But I'll write it anyhow. But it doesn't matter here. On the right-hand side, I have some variable term less than some number. That's an and statement for sure. So I know that's an and statement. And on the left-hand side, if I read it backwards, we've got really absolute value of 2 minus r is greater than 1. That's an or statement because I see the greater than. So that's going to be an or there. And now I'm going to break them up. 2 minus r less than or equal to 2 and 2 minus r greater than or equal to negative 2. That's what I get on the right side. Again, I'm using what Charles told us in the very beginning. I'm breaking this into 2 components. Okay, and I'm remembering to flip the sign and negate one of them. I need to do the same on the left-hand side. So I'm going to start by repeating my statement of 1 is less than 2 minus r. And then I'm going to also write it with the negation. So negative 1 is greater than 2 minus r. I'm putting lines down here to split stuff up so we can see the 4 solutions we're going to get. Okay, but that's what we have in this problem. It's just a little bit complex because you have an absolute value within a compound inequality. And then those absolute values cause you to have 2 compound inequalities each, giving you 4 inequality solutions at the end. So we need to find all of these solutions and think about what they look like together, all of them on a number line. So on the left-hand side, I want to solve for r. I could subtract 2, or I could move the r over and subtract 1. Either way, it doesn't make a difference. Let's subtract 2. So I get negative 1 less than negative r. And if I divide by negative 1 everywhere, I'm going to get 1 greater than r like that. That's my first one. How about the second column? What would the second column look like? How do I go about solving that one? Go ahead, Lucas. Step me through it. Second column.
Second column, that is 1 is greater than 2 minus r. So that means you subtract 2, that's negative 3, it's greater than negative r, and that's 3 is less than r.
Third column. Third column, what do I get? Mike, help me out with the third column.
Subtract 2,
Good.
and that would make it negative r is less than 0.
So how do I get r by itself? I have negative r right now, right?
Yeah. And, well, no, yeah,
Multiply or divide, pick whichever one.
multiply it by negative 1.
Good, which is still 0, but what do I have to do? Good. Okay, remember there, that's the tricky part. Don't stop. You have the negative in front of the r. You have to flip the sign there. And the last part, Nina.
I added R to the side,
All right, taking the alternate route. I like it. She added r over,
and then added negative 2, regular 2.
and then added 2 to this side. Okay, to avoid that whole flipping the sign over and over again. By the way, notice here, if you had this part right here, if you just added r over to this side, right? Watch, take this and add r over. You get r over here now, right? You get a 0 over here, telling you that r is greater than or equal to 0. Well, it's the same thing as dividing by -1. So if you want to do that instead, remember, you could just simply add r to both sides here. And you'll end up getting r written like this. It's the same thing as the above statement, okay? So we've got 4 statements right now. And it looks like those 4 statements can be written in tandem on one number line. Now, it might be useful for me to write them with the words or and in between stuff, though. So let's do that, and let's write them all with the variable on the left. It makes it a little easier. So the first one I'm going to write as r is less than 1, or r is greater than 3. That's that whole piece. Then this original thing was an and statement, if you remember from the beginning. And then r is greater than or equal to 0, and r is less than or equal to 4. So this is what's happening now. And it's really a bit, it's a busy problem. There's a lot going on. Okay, r is less than 1, or r is greater than 3, and r is greater than 0, and r is less than 4, less than or equal to 4. What would this look like on a number line? How would I graph all of these things? How would I graph all of these? Give me a beginning piece. How would I start it? Just start on the left-hand side for now. Start on the left-hand side.
0, 1, 3, 4, 5.
Say again?
The number is 0, 1,
Good.
3, 4.
0, 1, 3, 4. Agreed. Okay, why are you picking those points?
Those are the solutions.
Yeah, they're like the endpoints or the solutions, if you will, right? Even though we know they're not the actual solutions. All right, good. What do I do next? Sabine?
An empty circle over, a point over 1 that goes to the left-hand side.
All right, because I see r is less than 1. So I start by doing that. Agreed? What about next, Paul? We did r is less than 1. What's the next part?
R is greater than 3.
Okay, so open circle, and then which way?
Right.
Good. Now, that is my solution for the left-hand side. And then I see the word and in the middle. And means we need to look for overlaps now, don't we? So when I see the word and, I need to then graph the other part and look for where these overlap. So I'm going to use another color for now to show that. How do I graph this right-hand side? R is greater than 0, and R is less than, greater than or equal to 0, and R is less than or equal to 4. What would that look like on my number line? Nina?
Put an open circle over 0,
A closed circle over 0, agreed.
and then a closed circle over 4.
And then?
Connect them.
Shade in between, very good, connect them, all right? So that is exactly right for this part here. So I'm using the colors so you can see what I'm referring to in each statement. Now, those solutions that are currently on my number line are linked by this word and in the middle, because the original inequality was a compound inequality. If they're linked by the word and, we're really looking for their intersections, which are here, here, and here to here. So my final answer would look like this. Closed circle, open circle at 1, open circle at 3, closed circle at 4. Okay, that would be my final solution down here on the number line. You can practice writing that in solution set form on your own if you'd like, but that's what it would look like, because that's where the overlap is, where there are 2 of those lines on top of each other. Okay, practice tonight, make sure